Welcome to my talk, Nim times AI. I'm Treeform, and I'm going to explain you how I use Nim together with artificial intelligence coding agents. I started programming with QBasic. Back then, I did not have access to the internet, so I had to learn programming from books. Programming from books was very different. You couldn't write programs that were very complicated because there just simply wasn't enough knowledge out there to consume. I had to reference a lot of reference manuals. Like you had to, basically, I would read programming books from end to end, trying to retain some of that knowledge so that if I need it again, I can go back and say, hey, I remember it in a book, and then go find it. Like you basically had to index the books in your own brain. And reference stuff, I had to read the references for what the function arguments were, what the different assembly opcodes were. There was just a lot of stuff that was required to be learned, almost memorized. Programming was very different. Then one day internet came, and it was very cool. You could just Google stuff, Google answers to your problems, Google different documentations for different things. It was very different way of programming. Programming with the internet is far superior than programming with books. There were a lot of forums back then on the internet. One of my two most famous, the best forums I went to was the Game Dev forum and the OS Dev forum. And so I visited those frequently. I could ask questions. I could see questions that were being asked. I could even download code that people have written. In the era of books, downloading code was basically not there. You could maybe retype some code from a book, but it wasn't the same. Here, I could download full running programs and play with them, modify them. This was a whole different way of programming, and it was a monumental shift. We are going through the same monumental shift right now. I think coding agents have changed programming drastically, just like the internet has changed programming. With coding agents, you don't have to memorize APIs. You really don't have to read documentation. You could just ask questions. Coding agents are great at rubber duck debugging and brainstorming. All those things are now possible, something that you can't do with Google alone. And mainly, they allow you to write code, a lot of code. So the coding has been shifting from just typing in code and actual architecturing or actually providing intent behind the programs. And now the programs that you can write are far more larger and far more intricate and complicated than you could have accomplished before. But then, in the age of AI, what does a programming language even do? If you think about it, maybe you should just use the most popular language out there, because the coding agents, the LLMs, they have the most examples of that language, so they can probably write programs the best for the language that they have examples of. So, like the popular language, like JavaScript or Python, why just not use those languages? But I still think Nim has an advantages. One of the advantages is culture. Something that I find when writing JavaScript or Python with LLM agents is they actually write a lot of boilerplate. A lot of JSON in case of JavaScript or YAML when you're doing Python, a bunch of abstractions. That is basically the cultures of those languages, right? Importing tons of libraries, having big dependency trees. AIs are great at mimicking that, but it's actually not something that you want. I think with Nim, you have a minimal culture using small number of libraries, usually not using that many abstractions. It is the culture of a Nim program. So you kind of inherit that when you write programs. I think it's a superior way because the code is much more easier to reason about. It is much more clear. It's less files. It is interesting that I think the culture of the language matters. And here the minimalism of Nim really shines forth. One another important thing is static types. When the AIs write JavaScript or Python, sometimes they make little mistakes that they do not catch themselves because of dynamic typing. They will pass an integer to a string, or they can transpose arguments. The compiler doesn't tell them. And if this was not on the main path, you might never even see this error. If AI also did not write tests to test this. That's why many people actually use something like Pedantic for Python, which introduces types, or something like TypeScript for JavaScript, for this exact reason. Because types are actually great, and they help the AI make sure that the AI writes the correct code from the very beginning. Another thing I think Nim has the advantage is it's easy to read. It's basically runnable pseudocode, just like Python. Python is easy to read, Nim is easy to read, so I highly recommend that. It's, again, because of the Nim's culture, it doesn't create that many abstractions or import that many libraries. So again, that also makes Nim easy to read. Because now, with AI's writing code, we spend way more time reading something than writing it. So being easy on the eyes is very important, and Nim has that. Another important thing that Nim has is performance. You want a performant language. If you're going to have LLM write all this code and create all these types, why would you use Python with Pydantic, which does checks the types but doesn't make it all that much faster? So it is really important, I think, for whatever you are generating with AI to kind of be very good at performance, because why not? It's just a makes sense thing to have. One thing very important for AI agents writing code is to create the right verify loop. It is crucial. Karpathy calls this maybe like an agent researcher or auto coding. There's like a bunch of names for it. But the idea here is that LM writes the code, then it verifies the code. If it finds a problem, it fixes it and it verifies it again and again. If the LLM and the coding agent is stuck in this loop, it produces way better code. So as faster as you can get this loop going, the better. Sometimes a human is in the loop where it has to do some sort of final verification step. But really, the entire thing should be automated as much as possible. AI, I think, is really good regurgitating code. So, for instance, if libraries exist for whatever problem you want to solve, but sometimes they're giant, they're ginormous, they include other libraries, you could ask the AI, hey, can you just take that small part of the library and put it into my project? And usually it does a really good job. It's really good at like searching, and so you can take, if you take a modern website and you take all its dependencies, it could be hundreds of thousands of lines of code, but you can say, hey, I want to reduce all of that. I want to reduce all that as much as possible so it's testable, understandable. A lot of times the AIs are really good at reducing code, reducing complexity. They're also really good at creating complexity, so it's a double-edged sword. But this code reduction thing, I think, is underused in the AI world, where you can just extract the exact things that you need from a library. Another big thing that's happening with AI code is all the AI code that you don't care about. There's parts I care about that I would call the interesting parts of a program, the parts that are maybe specific to whatever domain you're trying to solve, or like the game loop or the game that you're making. And then there's a bunch of uninteresting parts of the code that you don't really want to look at. The AI really takes out the drudgery of writing this uninteresting code. As long as you test it well and you put it in the auto coding loop, is great. You can write a bunch of this kind of drudgery, a bunch of this like API, a bunch of this code that like doesn't matter, and so you can focus your attentions to the parts that do matter. In the past, you had to basically stay awake for writing all this code, but now you can sleep through writing big swaths of codes that are just not important. I think AI is really good when you use it as a translator. Basically, taking code that's over there and putting it, maybe transforming it to over there. If you think of it as like transforming, I don't know, from Chinese into English, something like that, for code, it is great. So if you are writing a Nim program and there is no Nim library for that, but there is like a C# or a JavaScript or a Python library for that, you could just tell AI, hey, can you make it into Nim and only use parts I care about and do all this other stuff? A lot of times the AIs are really, really good at doing that. And so I use this property of the AI a lot. Next thing the AI is good is kind of related to the previous one, but it's, again, you're taking something that exists over there and putting it over here. But instead of AI doing it directly, you actually ask the AI to write a program. You go in one level ahead, a program that translates something that was over there, maybe some sort of specification, into code that turns over here. I think that's a very, very powerful model. Now, I want to talk about VMAT. VMath is one of my libraries. It's a vector math for Nim that gives you 2D and 3D vector math, matrices, multiplications, quaternions, all that stuff exists in VMath. Huh, that's pretty cool. But I found a bug. I was looking at a bug, and for some reason, when I integrated with the Jolt physics engine, the integration, just the quaternions weren't right. I had to transpose them. It was some sort of row major versus column major bug. But actually, here the AI was no help. At first, it said I had my row to major columns flipped, and then that was kind of a problem. Kind of confused me for a bit. Then it confused about memory order and display order. So this is like a quirk in OpenGL where the memory order is actually different from what they display on the page in the documentation. I don't know who came up with this, but it's like all messed up. Like I was really searching what was going on. Why did my quaternions require to transpose? It was so weird, and AI was no help. Maybe it was something in the coordinate system. Like I'm using the GLTF coordinate system, so it's z forward, y up, negative z right type of coordinate system. So maybe something is wrong with my coordinate system. Maybe this is not the actual coordinate system that I'm using. Like what's going on here? Like maybe that was the issue. Again, the AI was no help. I think AI is really not very good at space-time stuff. It's not very good when you're dealing with coordinates or time-based things. It just absolutely fumbles at this right now. The space-time is not good at all. And this is the exact kind of problem I run into VMAP. You just couldn't reason about these 3D coordinates really well. Turns out the problem was very simple. It's actually like one character, well, maybe in several places. I basically had the rotations wrong. I was using clockwise rotations versus counterclockwise rotations. I have fixed this since, but this is what the idea. And the AI was absolutely no help finding it. It blamed everything else but this. Eventually, when I found this, it was a very simple fix. It was only a couple lines in the VMath library, and then all my quaternions were correct. The interesting thing with this is that even though I was using clockwise for all the rotations, the VMath was self-consistent. Like there was no bug, right, in VMath. It was just not using the conventions everyone else was using, which is, kind of like a bug. And that's what introduced the extra transposes. So I wasn't some dum-dum who like confused row major or column major. All this coordinate system was just a simple sign error. And AI helped me find it. But to solidify, to help me find this, to solidify that I'm absolutely correct, I had to do one other thing. AI is really good at taking stuff that is over there and putting it over here. And how I used here is actually took other libraries and made sure that they are or they match VMath 100%. So here's like a bunch of tests that I told the AI to write, and I tried using different libraries. One of the libraries I tried using was NimGLM, which is a port of the GLM, a very famous library to Nim, and I made sure that I'm 100% compatible with it. Like everything I do, it does exactly the same way. But that's a Nim library. I was not satisfied. I went into then look at geometrics, which is actually a JavaScript library made by Kronos themselves, the ones that made the GLTF and OpenGL. So it's like their library is probably exactly what we need because they all do stuff exactly that they would do for the specifications. And soon enough, the AI was great at writing this. Then originally I wanted to integrate with Jolt Physics, and Jolt Physics has its own matrix and vector stuff, so I need to make sure that I'm completely compatible with it. And I had the AI write tests the same way, and Jolt Physics passed them as well. The only thing that Jolt Physics does differently is the perspective matrix, because it creates the DirectX one, and then it also does the column order element access, because that's what's common in DirectX. So it's a more of a DirectX library. But everything else, except for the missing features, matches. But I was not satisfied with this. I wanted to go in deeper. So then I wrote a GLSL test as well. So this actually runs the tests on the GPU. This means like the multiplication and stuff is burnt into the silicon, which I thought was very interesting. And I did it the same way to make sure that everything is exactly matching what GLSL will do, which is what GPU silicon will do. So this put to rest all of my other doubts that I had with VMath. And I think previously this was just too much drudgery. To learn this test would have been too much drudgery in the past, but now the AI can just whip them up really quickly. And I think this is really where the power of AI really shines, is in doing this drudgery work. Next, I want to talk about GLTF. GLTF is a 3D format, and 3D formats are really complex. Through my career as a programmer, I have parsed numerous 3D formats, starting with the simple lakefront objects, going to MDL from Quake, going to like 3DS, and a bunch of game-specific one like for Homeworld and Total Annihilation. Those specific formats, they were all very different and they all code very different things, and they were all very annoying. Then came the Collada format, actually by Kronos as well, by creators of OpenGL. It was actually quite easy to parse. Finally, a format where all this 3D software can talk together through it. It was great. But Collada format is XML, it was verbose, and every program generated a slightly different version of Collada, which was like very annoying. I think GLTF fixes a lot of this. I really like the GLTF format. It features a small JSON core, which defines like the nodes of the hierarchy and a bunch of the properties. But for vertex information or just large numerical informations like animations and stuff, it does big blobs, binary blobs, and it's great. It basically is, I think, like it does a good thing on both worlds. JSON header, very easy to parse. You can humans can look at it. You can quickly see what it is. There's tons of JSON parsers. You can immediately see what's going on in the hierarchy. It is so nice to be able to basically view it. But then the stuff that actually would make JSON slow by embedding every little number, every little float inside JSON is not there. It points to the binary buffers inside the binary payload. I think this is genius. I think like most formats should be this way. A small JSON core that defines the structure and a bunch of binary things that do that does the majority of the data. And so I highly recommend this format. It's really great. One thing that I did for this format in order to make Nim loaded is the test suite. Test suite was one of the more important things that I started on. I did have a slight GLTF loader before AI really came this powerful. But then I knew if I wanted to improve it, I really need to get AI in the test suite. So I had the AI write the test suite where it loads all of the GLTF models, all the examples provided by Kronos, and then seeing, do they render right? How do they render, right? And now I have this test suite for every model. And whenever AI makes a change, I can go in and I can look, hey, well, what type of things changed, right? I can see, I have a little X-ray viewer that allows me to see changes and a little thing that allows me to see difference from master. This is really cool because then I can tell you, hey, this thing doesn't look right on this image here. And then it goes and tries to figure it out. And it fixes, it might fix it for that model, but then it might break it for all of the other models. And that's not good. This prevents the AI from doing that because AI can go into this auto loop and just go, hey, I fixed this thing, but it actually broke a lot of other things. I need to keep working on it. And it will keep on crunching and crunching and crunching until it fixes this model. But then it goes on and makes sure that nothing else really was broken. And so, but then, as a final verification step, I, as a human in the loop, need to go and verify that the models are actually looking how I think they should be looking. And so it's an interesting thing. Like AI could do a lot. I would not have gone through all this drudgery. There's just so much in the GLTF, in the animations, in the morphing of vertices. There's just like so many different parameters. Like I would just not have patience to do them all. The way I did it is just I implemented stuff that I was interested in that was needed for my game, and that's it. So I had an incomplete GLTF thing. But the AI can actually finish it now, which is great. This write verify loop really saved my bacon and really elevated the GLTF importer for Nim and renderer, right? It really elevated it with a complete 100% suit. Another thing that the AI is good at is looking at all the other GLTF libraries out there. There's not really a GLTF loader for Nim yet, but there are GLTF loader for JavaScript, for a bunch of other languages. You can just point the AI at it and say, hey, if you can't figure out how to do something, look at how it's been done in all this other a bunch of libraries. And they have numerous files and they're really complicated. They're actually quite more complicated than my library, or even though they kind of do the same thing, but because of mainly because of abstractions. My library, the way I like to write software, is a lot less abstractions. So I was able to basically distill all these different GLTF readers into like a single small Nim GLTF reader that is very compliant. AI is really good at this. You can see this is all the things that I've like rated my loader on, and you can see it supports a lot of things that even some other GLTF loaders on the web don't support. So it's really cool. I'm basically getting closer and closer to full support of the GLTF spec with the AI, and it's something that just wouldn't be possible. It just wouldn't be like interesting. It would have been fun to do previously, right? It would just be a bunch of drudgery. But now I can do like a lot of stuff. I think with AI, with the right verify loop, with the AI ability to regurgitate large amounts of information. Next, I want to talk about graphic APIs. This is again a great example of taking something that's over there. The graphics API already exists. There are already people using it a lot, and putting it over here, putting it inside a Nim so that Nim can use it. I think it's like very powerful part of what AI can do. One of the things that I want to do is experiment with DirectX 12. I have been using OpenGL for my games for basically my entire career. Kind of stayed away from DirectX because I'm not some Windows fanboy. But the reality of the situation is that OpenGL is deprecated and Vulkan is just not quite there yet. All the big players are basically attacking open source graphics libraries. So the reality here, they're just not that great anymore. And with the Steam Deck and whatever Valve is doing on Linux gaming, like it is actually easier to ship a Windows game with DirectX on Linux than it is to write a Linux game on Linux. It is wild. Like the Win32 API and the DirectX 12 API is just so stable, while whatever Linux does is not stable. I've run into that in my own game where I shipped a game and it still runs on Windows fine, but Linux, because of its like constant compatibility changes and stuff in userland, has broken it, and so I have to like refresh it every year, and I just don't. I don't have time for that. But my Win32 game works just fine. It's crazy. So for DirectX 12, I want to experiment with it. I want to learn about it because it's probably the best gaming API now. Right? It is used by the most AAA titles, etc. So how do I bind it to Nim? There wasn't really any good DirectX bindings, but AI can do it. At first, we weren't having much luck because Direct uses COM objects, and COM objects are complicated, and whatever code it wrote was extremely not Nim-like because of COM objects, right? But eventually, I got it to where it looked decent in Nim, and you could use DirectX 12, and that was great, and you can use it too. It's one of my libraries. But the way I achieved the ultimate thing is parsing the IDL files. Turns out the Wine project, the same project that like Valve uses for Proton and to run DirectX games, publishes these IDL files, which basically describe the API programmatically, which is great. So instead of trying to generate asking the AI to generate the DirectX API from like header files or from your documents or something, I actually just wrote the AI to write an IDL parser. And then that IDL parser generates the DirectX API. So I'm not making the AI write each individual call, each individual type, because it'll make small mistakes like here and there, and then they'll never be tested because if I don't call that rare call, I do not know if it works or not because the AI might have hallucinated a call parameter or something. But when we parse the IDL files, we know exactly that if we can call most of DirectX IDL, we probably, even the untested functions are probably good. I'm pretty confident that that would work as well, because the IDL just defined them. The IDL parser is much smaller. Once I get it right, it can parse any IDL file and generate any Nim-esque API for it. So that's what's great. That's how I got DirectX 12 to work, and it's amazing. It works. It's great. With the success of DirectX, I went on to the second thing, Metal. So on Mac hardware, Metal is the king. You probably want to use Metal directly. So here I did a similar thing. Here I parse Objective-C header files and generate a Nim-like API. Objective-C is a very, very different API from what we're used to, guys, and the header files, they don't look like the header files you're used to from C. But I had an AI eventually figure out how to parse the Objective-C glob, and then I can generate the Nim stuff that calls it, and it's great. Or I can use Metal directly in my stuff. It is much much better than before. Previously, metal was just like, yeah, something that exists somewhere and is like almost unattainable. But with AI, I can now generate the whole API and make it also NIM-like, so it's comfortable to use from NIM. Because of the success of the Metal and DirectX one, I wanted to generate the Vulkan API, and this was a breeze. This was very easy because, again, Vulkan publishes their entire API as one large XML file. I had the AI write the XML reader, and it would just generate nearly, very similar NIM-like API for Vulkan, and that was great, and I'm pretty happy. And now I have Vulkan stuff working as well, which is great. Yeah, this is a great example where I'm not using the AI to generate the binaries directly. Instead, I use the AI to generate the program that then writes the binaries directly. And I think this like meta level is really powerful, and I recommend you guys use it more often. I didn't really use AI as much for this, but this is an interesting. Actually, OpenGL, the API I like, especially the 4.6 one, the DSA, Direct State Access Layer, is actually really good. I made a Nimified version of this API. Yeah, and it's actually really good. You just create a bunch of like what looks like Nim objects, and you just point them to each other, and just create this little tree, and then you render it. OpenGL actually had a good API living inside it all along. I just like was not aware of it, so that's pretty cool. Next, I want to talk about Nimi. So Nimi was just a little fun projects. Like I like now doing little fun projects with AI because previously doing a little fun project required basically, I would do the fun part of the fun project, but then I wouldn't do the drudgery, and so the fun project was always incomplete. It wasn't as good as it can be. But the AI now can complete the drudgery. It's amazing. So here I try to make a little scripting language that's like Nim plus Lua. But Nim is already great. Why would we need a different language? So I want this language primarily to be embedded in mods. So I'm making games and I want a little mod. I kind of just want to embed something. Like I don't want to make mod authors install a Nim compiler and then want ship DLLs to me. That sounds very kind of dangerous and weird. This is what the Nimi looks like. It looks exactly like Nim, except it doesn't have types. It's actually kind of weird. So looking at Nimi code is like, is this Nim? It looks like Nim, but it's like without types. It's actually pretty funny, like a pretty funny feeling that you get from looking at this code. A lot of Nim features are just supported, so it's surprising how Nim like the code looks like and how alien it looks like at the same time. Like functions that don't have arguments, and then like the object definitions that don't have types. But it's cool. It was easy to write. Um, I basically did the fun part about dreaming of the language, and then I did all the drudgery, which like I've written dozens and dozens of little languages before, and this was like the easiest thing to write and the most functional and complete thing I ever wrote because the AI took over all the drudgery for me. This is primarily made at game mods, right? So if you write a little game and you want a little mod for it, you might embed Nimi. It embeds in Nim very easily, just like Lua embeds inside like C projects. And then it's just a string. You execute a string and you get stuff back. I could have used Nim script, but again, Nim script seemed to be much harder to integrate. And this was just a fun AI project. This is primarily so you can run untrusted code. You imagine if you download a mod from someone, it might contain, it might start writing files to your disk, etc. So really pushing some sort of DLLs, or even I think NimScript has read file and write file like built in as primitives. None of that exists in Nimi. Nimi tries to be more sandboxed than that. So potentially you could use Nimi to run untrusted mod code, but AI wrote it, so don't trust it 100%. But it's still way better. If you were just shipping, I don't know, DLLs around compiled with Nim, that'd be crazy. One other thing I want to do with Nimi is the visual debugger thing. It was something that NimScript didn't really have his ability to step through. So it's kind of put breakpoints and step through breakpoints. So this is like the very big, really early design for Nimi was ability to kind of really easily debug it, make it almost like a learning language. If this was someone's first language, like this is the first time you make a mod for a game, I really wanted to make it easy. Like if there's an error, it could just pause, it could point you to an error. You can inspect every variable in that stack trace. You can go up and down stack traces. And of course, you have a little console where you can just write Nimi code in line, right? And it will it will run in the same kind of context as your current broken states. So you could like breakpoint here inside the greet function, and you can, see what the different parameters are, and if you call something, what happens. This is really cool. This is how I like learn programming with QBasic and like other things. So I really wanted to have this very easy, very very flowy type of thing. So I thought this was great, and this was primary demo for Nimes to be able to have this graphical type thing. Yeah, it's just a fun project. I don't think it's something serious. I don't even if I want to know if I want to ship it inside my games or just something funny to tinker around with it because AI makes it fun to tinker around stuff. It's interesting, right? And again, they had like parts that I cared about, which is like having like sandbox and being able to set breakpoints and having nim syntax and largely nim semantics, well, a little bit. And then a bunch of AI code to generate. I did not care about one bit. Just AI, do whatever you want. I just cared about the fun parts. And this is the most complete scripting language I probably ever made. And it was very easy. It was very cool. So I really enjoyed this project. I highly recommend doing something like this for your stuff as well. Again, create the right verify loop. I had a good test case. The AI would just churn through bugs. Eventually, we'll figure them out. I didn't even know how I did it. Next topic, I want to talk about OS dev, operating system development. This is another thing that was always, in my heart. I used to write totally little operating systems all the time, but there's just a lot of drudgery to operating system development. It just gets to the point where it's not fun. But I think AI makes it fun again. Here I wrote a little graphical operating system. It features a bootloader, then it features a 64-bit mode, so it goes basically goes all the way to 64-bit by going through the 30-bit 2 mode before. That all happens during the booting process. So it's really cool. Most operating systems, most hobby operating systems out there, they're still 32-bit modes. So this is cool to have a hobby 64-bit mode operating system. It has a graphical shell. It kind of reminiscent of like Windows 95 or something, like something pretty early. Yeah, it has a graphical shell. It boots you into a graphical shell. You can click stuff around. It's really cool. It features a FAT32 file system. FAT32 is it's ubiquitous. It's everywhere. It's pretty well documented. I think it is still used in like SD drives, so it's a real one, and it just has so much I think OS history, and I just knew it from my past operating system experiences, so I just used it. So yeah, so that was cool. I had to implement malloc and a bunch of other libc like things in my operating system in order to make just average nim libraries run. And so, like, in order to get this run, I had to get Pixie running and Zippy running and VMath running. And so they rely on a bunch of little libc things, and I've stubbed them all out for this operating system in order to make this graphical shell run. This is like actually a lot of code. It loads the stuff, it reads the PNG images, which are all icons are PNG, but it could be SVG or anything else that Pixie supports. Then it also renders its own fonts. It reads true type fonts and then it renders them. It's actually quite neat of how far you can get with the AI. I cared about the graphical and running the NIM libraries, but the AI took the rest of the drudgery. This is probably the most like advanced operating system I have written so far, even though I've written so many little toy operating systems in the past. The fact that AI has removed a lot of the drudgery made it fun again, which is really cool. It's just fun writing these kind of things. I highly recommend having these projects. Again, there were a bunch of parts of the operating system I cared about, such as running Pixie, able to be graphical in order to be 64-bit. And then there was just a lot of parts I did not care about at all. I just want AI to solve it. And AI did solve it, right? And that was really fun. It was like a very lightweight, really fun project. And again, you put it in the right verify loop. You boot the operating system, you make sure the tests pass, you do this thing, like the AI just does it for you. It is great. And whenever it finds like weird mistakes or edge cases in the hardware, it just like grinds on it until it works. It's amazing. Next, I want to talk about Softmax. Softmax is a company I work at, and it's a pretty interesting company, very different. It's an AI company, and we do AI alignment research. And it's very different for us because we do research slightly differently. But what's relevant here is we use NIM in this company. Not everywhere, but I use NIM a lot, and we use NIM for many different things. And so it's really cool. to do AI alignment research. I feel AI alignment is probably humanity's problem number one. How do we prevent some super intelligent rogues AIs from killing ourselves? Yeah, I'm not some sort of AI doomer that I think this will happen 100%, and so we must like destroy AIs or something. No, but if there's even a small chance that AI will get disaligned and will cause harm to humanity and even potentially destroy it, we should really think hard about preventing it, right? It just makes sense. The stakes are just way too high. Even if it's 1%, even if it's a half a percent, right? Like we really need to think about it. There's a lot of people thinking really hard about this at Softmax, and so am I. One of the main things that I think the other AI alignment labs are getting wrong is the fact that they're thinking in terms of rules, safeguards, but we're thinking in terms of nurture. You want to grow the AI. You don't want to impose rules to an AI because you have a large language model. It basically arrives like an alien from outer space. It doesn't know anything about spatial stuff, like it doesn't know anything about space and time. Spatial stuff awareness, it basically has zero. Time awareness, it basically has zero because it just didn't grow up with this concept. And it really doesn't have the theory of minds of other agents because it really didn't interact with those other agents during its creation. It basically is created from reading the internet, and then you have this alien, and it's a completely different thing to do with it. And so imposing rules on the things we feel will not work. It will not lead to some sort of grand theory of alignment. Instead, we want to grow the AIs through nurture by basically having baby AIs and putting them to play in games. Basically, we want to do it through games. We want to grow the AI through games. What we want to do is we want to put the AIs when they're still small and dumb into these game environments and then see how they behave. And it's really important that there are other AIs in those game environments and they can kind of see how they interact with each other and they can learn to interact with each other well. Just like humans, if you don't put, like a baby is born, we don't put them in an adult workplace right away. No, we grow them through playing games like in the sandbox. And this is how humans learn to be good citizens, right? Is slowly through school system and through this by interacting with other humans. And so, yeah, we made a bunch of small games. It is also very important that the games be multiplayer again, and they need to be like social dilemma games, at least vaguely, in order to in order to teach the AIs to be social, to have a theory of minds of other AIs. In order to try to solve a game, they need to solve how the other AIs in the space will try to solve the game. And this is really important to me. One of the games that we're trying out is called Crew Rift. It's basically a game inspired by Among Us. You go around the spaceships and you complete tasks. Some of you are actually imposters, the bad guys, and so you want to root out who the bad guys are. And so this is like a social deduction game. You need to know the theory of minds of the other agents. Every agent in this game is played by a different AI, and they can't communicate outside of the game. They can only talk through the game. So you have to like watch how the other players and other AIs navigate the world, the kind of tasks they complete, and they need to report dead bodies and then call for vote who they want to vote out. It's a pretty interesting game. It's pretty interesting to see how the AIs choose to play the game. Uh, that's one of the games we're doing. Another game of the game we are doing is Heartleaf. This is like a very cozy game where you farm some vegetables and then you invite other gnomes to your house for dinner, for a little party. This is basically a high school popularity contest game. You want to go around, you want to be popular, you want to feed everyone, you want to go to the most popular parties, you want to host the most popular parties, you want to be the most popular gnome in the little gnome village. And yeah, it's pretty interesting. It's like if Stardew Valley, if little every little person in Stardew Valley had their own mind and had their own agenda and would invite everyone and like was trying to like be nice and be a friend. It's actually a pretty chill and like cozy game to just watch or even be a human in. Because again, the AIs that communicate through text and you can talk to them. Yeah, I thought this was pretty neat and really interesting. And of course, we're doing our. I want to like get all the different types of AIs, types of games. Like we have a puzzle game. So here's blocks dropped from the sky, and you have to place them. So it's like basically kind of like it feels like a cooperative competitive Tetris, where you can cooperate or compete with other players in the world. Like you can either stack blocks together, or you can be antisocial and stack blocks in a very weird way. And so Yeah, and be basically like worse for the team, and sometimes you can steal other people's almost completed lines. It's actually kind of neat to see how AIs play this and how they at first kind of cooperate, and then when they don't cooperate, it's interesting to see them learning how they're going to work. Then we have an RTS, a real-time strategy game. This is basically kind of inspired by a game called Galcon. It's a very simple risk-like game where you move, where you collect planets, and planets give you spaceships, and then you send those spaceships to colonize other planets. And then eventually, the cool thing, interesting, is that when many people play it, many players are playing it, and it is a free for all. When many players are playing it, like some sort of like truces and alliances form, and the AIs have this concept of like honor. Like if you haven't attacked this player, they want to attack because there's honor. But if someone is dishonorable, they're attacked first. It's kind of interesting, the kind of things, the kind of mind games you can play in such a game. Another game we have is an RPG where you just go around and kill monsters. You can kill much larger monsters in a group. Like you almost want to have, your standard RPG archetypes like a tank, a healer, a DPS, a glass cannon on your team, kind of to kill as many monsters as possible. There's just some monsters that are impossible to kill in a row. But if you team up, you can kill a lot of people. But then this RPG has a dark side, is that you can always kill your other players and take their loot. So you also have to be very careful. It's very doggy eat dog world there. It's like very dangerous. But you can still form alliances and get progression, which is kind of really, really interesting. And then finally we have like a platformer game. So in this game, it's kind of like your average platformer. You're trying to go from one end of the level to the other, but you cannot get there without help from your other squirrels. So the squirrels actually have to help each other. You basically have to like boost each other. So in order to complete the level, some squirrels get through the level and they get to the end with the help. But the second round they go through, the person that helped them before can say, "Hey, I helped you to go through before. Now you help me." And then you have to like decide who's helping who, and it's kind of an interesting dynamic. Can you actually like rely on the generosity of strangers to get through? Can you self be generous and help other people to get through the level? It's actually quite an interesting dilemma that the AIs choose. We're also doing AI tournaments, and you can submit your own AIs to play these games. Just go to softmax.com/play. You can submit your own AIs. The games are written in Nim, and the players are also written in Nim. So get your coding agents and submit them there. It's pretty fun to play this. Again, this uses all of the things that I've talked about previously. You want your little agents running in a little write verify loop. It's like really cool. You get your agents in, you see the score, and then you ask the AI, can you improve the score? Can you use these strategies? I started being stuck that. So there's always a human in the loop, and then you see the AI is improved based on what you tell it. And then it can go and play and get a higher score. It's actually quite cool, quite addicting, I would say. Then, because there's already examples of games and players, you can actually regurgitate the other players what they've done and incorporate them and get the good parts and keep the bad parts out, and you can remix them, which is kind of really interesting. This is again a really powerful AI technique. Again, here's a lot of stuff for the AI player you don't care about, like how to like read the pixels, how to navigate the map. But like maybe if you saw your agent navigating the map like badly, you would maybe care about it more. But if the agent navigates the map pretty well, you don't need to care about that part. You only care about like the higher level social stuff. It's actually kind of neat how you can delegate a bunch of the code just to the AI, not really care about, but care about the main parts of your code. And knowing when to do that is really powerful. And again, having the AI be, so you're not making the AI play the game, you're actually writing an agent to play the game. So I think it's a more powerful technique. Again, you're taking something from like that exists to something that you want to exist in this game particularly. Softmax is also hiring if you live around San Francisco or want to relocate. So that's my talk. Nim times AI.